One tool of Aether that is quite useful is its data feeder. Usually, softwares try to feed data automatically. We have chosen a more graphical approach, and I'm going to demonstrate this. So to access this tool, we just need to click on it in the menu, and I'm going to load some experimental data. So this data is basically two columns with the X data and the Y data in a text file separated by a space. So when I select this, I get here the experimental data that I want to fit. As we can see, there are several features inside. There is an exponential decay and a bump, maybe Gaussian, maybe something else. To fit this, I'm going to need several models, of course, and I'm going to try to do this by hand. So my different models are going to be an exponential first, so I'm going to add this. So I'm clicking on Add Model, and I'm going to select the exponential here. And I have an exponential curve that has appeared with a box and its parameters on the left. Now, I'm going to fit this by hand, and to do this, I'm going to use the control points that are present on the curve, and with my mouse, I can place the control points exactly where I want to. Now we see that actually the exponential doesn't fit very well because there is an offset on our data. So to remove this offset, I'm going to also add a constant value. And this constant is going to be located here. But the data is actually the sum of this constant and the exponential. So what is quite interesting is that I can actually subtract this constant, and I get here my data without the constant. And now I can use my control points to fit precisely the exponential, and I can subtract it as well to get the remaining bump. I'm going to assume that it is Gaussian in nature, and to do this, I'm going to add a Gaussian, and in the same way, I can place it by hand around the bump and subtract it again. Now we see that, well, it's not fitting perfectly here, but we still have something maybe there. So I'm going to add a second Gaussian that I'm going to place at this location. Now, this fit is not perfect because this is done by hand, but this can serve as a good starting point for an optimization step, which is present here. And so at this point, I just need to click on Optimize, and the software is going to try to optimize our model based on where we started. So it's going to be able to quickly get something as good as possible given what we have here. And at the bottom here, we can see the error actually between the original data and the full model. So let's have a look here. So we can say that this experimental data was fitted with one constant, one exponential, and two Gaussians, and that's it. It's as simple as it goes.